Hello, Algebra 2. This is 731 and 741. So in 731, we're finding the domain of a radical function, and in 741, we're solving equations that have one or more radical expressions in them. So we're going to start off by finding the domain of a radical function. So in the handout you're given some examples of radical functions, and these could look anything like this 3 times the square root of x to the 5th minus 7, or you could have something that looks like this, 3x minus 2x to the 1/2 plus 5. Now, it's pretty obvious that f of x is a radical function because we have a radical inside of it. We've got the square root of x to the 5th. Now, it's not so obvious that g of x is a radical function. What we have is this x to the 1/2. And that is a radical. It's just written in exponential form. This x to the 1/2 is the same thing as the square root of x. And so g of x, we could write this as 3x minus 2 root x plus 5. Okay? So things that have fractional exponents can count as, or do count as, radical functions, and we can use the same rules on them that we use on radical functions. Okay? So the domain of a radical function, it's the set of real numbers that makes the radical expression a real number. And so there are two things that we can say about the domain of radicals. Well, there are basically two types. Let's start with this. There are two types of radicals. There are radicals with even roots, and these include things like the square root of x, the 4th root of x, the 6th root of x, and so on and so forth, right? So even roots, their roots are even numbers. The square root of x, that has a root of 2, we just can't see it. And then all of these things can be written, we can rewrite these in exponential form. We have x to the 1/2, x to the 1/4, and x to the 1/6. Okay, so this is one type of radical, and that's going to make a difference in how we find our domain. And then the other type of radical are radicals with odd roots. Okay, so these are the cube root of x, the 5th root of x, the 7th root of x, and so on and so forth. So their roots are odd numbers, and we could rewrite these as x to the 1/3, x to the 1/5, and x to the 1/7. And the fact that their root is odd is going to make a difference in how we find their domain. So how you find your domain of a radical function depends on whether or not your root is even or odd. So I'm going to say that again. How you find the domain of a radical function depends on whether your root is even or odd. Okay, so if we go over that, so let's see, radicals with even roots, okay, so something that we can say about them, they cannot have a negative number under the radical. Okay, if you have an even root, you can't have a negative under the radical. So that affects how we find our domain. So to find our domain, so we can say, to find the domain, you take what's under the radical and you make an equality and you set it greater than or equal to 0. Okay? By setting it greater than or equal to 0, you're saying that it can be 0 or positive. So I can put that in parentheses. this means it can be 0 or positive. Or maybe not to say it can be, maybe a more exact or definitive thing to say would just be, this means it has to be, okay? It has to be 0 or positive. Whatever you have underneath the radical of something with an even root has to be 0 or positive. So you take it, you set it greater than or equal to 0, and then you solve to get your domain. And we'll do some examples with that. Now, radicals with odd roots, this is nice and easy. So if you're a radical and you have an odd root, right, cube root, fifth root, seventh root, and so on and so forth, I'll put this in big bold letters, you can have a negative or positive, doesn't matter, under your radical, okay? If you have an odd root, you can have a negative or positive number under the radical. And your domain, you don't even have to do any thinking to find the domain of these. The domain is always all real numbers. So you just write that and go on and you're all done. Okay? So for radicals with odd roots, we don't have to do much thinking. The domain is just all real numbers. So this can be if your root is odd, or this also counts for fractional exponents with odd denominators. Okay, fractional exponents with odd denominators. So what I'm talking about, let's say you have a function of x raised to the 1/3. Okay, if your function is x raised to the 1/3, so this has a fractional exponent. The denominator is 3, which is odd. So then this is all real numbers. Well, your domain is all real numbers. Yeah, so we would say your domain is all real numbers. Because if you have x to the 1/3, well, that's the same thing as the cube root of x, right? Which is then a root with an odd root, okay? So that domain is the exact same thing, all real numbers. Okay, so if your root is odd, you don't even have to think, you just write all real numbers. Now, if your root is even, you're going to have to do some work. So if your root is even, let's see, we can go through, well, if we take a look at the example that's in your handout. So the example that's in your handout is done out for you, but I'll just go through it. So we have f of x is the square root of x plus 5. And for this one, you have to find the domain. Okay, so to find the domain of this, well, this is a square root, which is an even root. Okay, so we just take whatever's under the radical, which is x plus 5, and we set it greater than or equal to 0, and then we solve for x. So then I would minus 5, and I get x is greater than or equal to negative 5. And so we can say for this particular problem, the domain is x is greater than or equal to negative 5. And that's all you have to do, and you're all done. Okay? For example 2, you also have to find the domain, and the function that they give you there is f of x is the cube root of 2x minus 6. Okay, well, this is an odd root, so you don't have to do any thinking, and you can say that your domain is all real numbers, and you're all done. Alright. let's take a look at, let's see, so they give us some more examples. So we'll run through some of these. Let's see. So for all of these, you have to find the domain. So for number 1, we have f of x is the square root of x minus 5. Okay, so square root, this is an even root. So I take whatever's under my radical, x minus 5, I set it greater than or equal to 0, and I solve. So I add 5, x is greater than or equal to 5, and so this is my domain, and I'm all done. For number 2, we have g of x is 3/4 times the square root of 4 minus x plus 3. Now, this is an even root. It's another square root, so it's an even root. When you're finding the domain of a radical function, all you care about is what's under the radical. Anything outside of that you don't care about. So this 3/4 doesn't matter when we're finding our domain, and this plus 3 doesn't matter when we're finding our domain. So all we're going to do is take that 4 minus x that's underneath the radical and set it greater than or equal to 0. And then we'll go ahead and solve this. So minus 4, negative x is greater than or equal to negative 4. Well, if I kick this up here, because I need a little more room to work, so I have negative x is greater than or equal to negative 4. I really want a positive x, so I'm going to divide everything by negative 1. And then when I do that, I'm going to have to flip that sign. So I'll get x is less than or equal to positive 4. Okay? So any number less than or equal to positive 4, if you plug it in here, it's still going to have a positive. It still works out. So that's our answer, and we're all done. For number 3, we have r of x is 5x root x plus 1. And again, we want to find the domain of that. We've got a square root, which is an even root. Okay? When you're finding your domain, you only care about what's under the radical. And so the only thing we have under the radical is this x. So we say x is greater than or equal to 0. Well, we already have x isolated and all by itself, so we're all done. For number 4, we have a fractional exponent. So we're going to have negative 2x raised to the 1/2 plus 3. Okay? So this is an even root, okay, because my denominator is even. So if we wanted to rewrite this function here as a radical, this would be negative 2, the square root of x plus 3. So notice this 1/2 is attached to only the x, okay, so the only thing that's inside the square root is x. The negative 2 is not in parentheses, it's not affected by the 1/2, so we keep that outside. So when you're finding this domain, you only care about what's inside the radical, which is x. So we could say x is greater than or equal to 0. And in that case, x is already by itself. So that's our answer, and we're all done. For number 5, we have big C of x is negative 2 times the cube root of x plus 3. So we have a cube root, which is an odd root. So we don't have to do any work, and so we can say our domain is all real numbers. Alright, we take a look at number 6. So for number 6, we have big C of x is equal to the 4th root of 3 plus x, the whole thing cubed. Alright, so this is an even root, right, because our root is 4, so we have to take what's inside the radical, which is 3 plus x, the whole thing cubed, and set it greater than or equal to 0. So the first thing we want to do is get rid of this cube here. Well, you can get rid of a cube by taking the cube root of something. So I'm going to take the cube root of the left side, and then what you do to one side of an equation or an inequality, you have to do to the other. And I'm also going to do the cube root of 0. So on the left, my cube root and my cube go away, and all I have left is 3 plus x. And then on the right, well, the cube root of 0 is just 0. So now we solve for x. Minus 3, and then we get x has to be greater than or equal to negative 3. And that's your domain, and you're all done. The next thing that comes up in this section is radical equations. Okay, so radical equations is part of 741. And we can solve radical equations by getting rid of the square root. And so an example of a radical equation, well, if I take what's in your packet, you have the cube root of 2x minus 5 plus x is 7, and we have the square root of x plus 1 minus root x is 4. Okay, so a radical equation, it's just an equation that has a variable in the radicand. And so how we get rid of these is we get rid of the radicals. And one of the ways that you can get rid of the radicals is by raising everything to the same power that is the root of the radical. So for example, if we wanted to get rid of this cube root, we would have to get this cube root by itself and then raise everything to the power of 3. So we would probably subtract this x and then raise both sides to the power of 3. And then to get rid of these square roots, we would have to square everything. Okay? So you have some steps written out there, which I'll let you read on your own. And we'll jump into the classwork and do as many examples as we can. So for number 1, I have the square root of x is 3. And so to get rid of that square root, I'm just going to square both sides of the equation. So then I'll get x is 9. And that's my answer, and we're all done. Let's go on to number 2. So for number 2, we have the square root of a is 7. So to get rid of that, I'm just going to square both sides, and I'll get a is 49. And we're all done with that. Number 3, root x is 6. And so I can go ahead and square both sides, and I get x is 36. Okay, and of course you can always go ahead and check these by taking these numbers that we're finding and plugging them back into the radical to see if it works out. So for number 2, if we take the square root of 49, we know that's 7. For number 3, if we take the square root of 36, we know that that is 6. For number 4, we have the cube root of a is 2. So to get rid of a cube root, we're going to cube everything. So we'll take the cube root of a, raise it to the 3rd power, and then on the other side we have a 2, and we'll raise that to a 3rd power. So on the left, the cube root and the cube cancel, and we get a is 8. And that's our answer there. Let's see, for number 5, we have the cube root of x is 6. So I'll cube both sides, and I'll get x is 216. Okay, so going on to number 6. Number 6 has a little bit more going on in it. For number 6, we have to do the square root of 3y, which is 12. So we want to get rid of this square root. So we will take both sides of the equation and square them. So on the left, we'll get 3y, right? Because if we square that, that'll cancel our square root. And then on the right, well, 12 squared is 144. So then we can go ahead, divide everything by 3, and y is going to be, let's see, 144 divided by 3, y is going to be 48. So your answer to number 6 is 48. Alright, so going on to number 7. So for number 7, I have the cube root of 3x is negative 6. Okay, so to get rid of a cube root, we're going to cube both sides. So I'll raise both sides to the power of 3, and I'll get 3x is equal to, let's see, negative 6 cubed. That's going to be negative 216. So we'll divide both sides by 3, and x equals, let's see, 216 divided by 3, 72. So x is going to be negative 72. For number 8, we have the square root of 3x is negative 6. Now, for this problem, we have the square root equaling a negative number, which is impossible because a square root can't be a negative. So, let me think about this one for a second. Yeah, I think we're going to go with no solution here. Yeah, square root of 3x equaling negative 6, that's going to be no solution. Whenever you have an equation with a square root equaling a negative, it's just a no solution. If this was a cube root or any odd root, then that would be fine, and you can go ahead and do that. Alright, for number 9, okay, for number 9, we have the square root of 3x plus 1 minus 7, 0. So we haven't seen anything like this yet today. In this problem, we have a radical with something being added or subtracted to it on the same side of the equal sign. So what we want to do is get this radical by itself. So I'm going to add 7 to both sides. So now I have root 3x plus 1 is 7. Okay, so now what we want to do is we want to get rid of this square root, so we can go ahead and square both sides, and that'll give us 3x plus 1 is 49 minus 1 minus 1. 3x is 48. We'll divide everything by 3, and x is going to be 16. Okay, so your answer there is 16. Alright, so we'll go on to number 10. For number 10, we have the square root of 5x plus 1 minus 4 is 0. Okay, so we'll add 4 to both sides. Again, we want to get this radical by itself. So I have the square root of 5x plus 1 is 4. And then to get rid of my square root, I'm going to square everything. So I'll have 5x plus 1 is 16. So now I'm just solving for x. So 5x is 15 and x is 3. And we're all done. Now, number 11 has something new again. So we have root 3x plus 5 equals root 4x minus 1. So for this particular problem, we have a square root on either side of the equal sign. So we want to get rid of them. So we can just square both sides. So I'll square the left side, and I'll square the right side. So in both cases, when we square them, the square roots are going to disappear, and we'll have just 3x plus 5 is 4x minus 1. So now this is like an equation that we had from the very beginning of the year, and we'll just go ahead and work it out to get x by itself. And so our answer there, x is 6. And so we have a similar situation for number 12. So for number 12, we have the square root of 2x plus 3 is equal to the square root of 5x minus 9. So again, we'll go ahead and square both sides, and that'll cancel our square roots. So we'll have 2x plus 3 equals 5x minus 9, and now we just want to get x by itself. So let's see, subtract 2x, 5 minus 2, we'll get 3x minus 9, add 9, 12 is 3x, so then x is 4. So those are all of the classwork examples for 731 and 741, so hopefully you can go ahead and do the homework on your own.